Welcome to NIOS live classes. Subject Science and Technology, Class 10th. Book number 212, Module number 4, Energy. Lesson 13, Work and Energy, Part 4. In Part 3, we have learned various things like relation between work, force and displacement. We have also learned how to calculate work done by a force. We know the energy and its actual meaning. And also the relation between work and energy. The SI units of work and energy, which is joule, and also the examples of energy transfer and energy loss. Now, before starting this part, let's learn some difficult words so we can understand it clearly. First is vibration. Vibration is the fast back and forth movement, like vibrating string, or spiral spring, pendulum and turning forks. Next is velocity. Velocity is in speed of an object in a specific direction. For example, a car moves a house to school, so the speed it has used is called velocity of the car. Next is mass. Mass is the amount of matter like how heavy is that substance. Next is atom. We all know that the atom is the tiny particles of matter. And next is nucleus. Nucleus is the center of an atom. It includes neutrons and protons. Next is turbine. Turbine is a machine that spins to produce energy. It moves through the air and gives us energy, so we can use it. We have completed our difficult words. Now let's start our part. After completion this part, you will be able to explain energy transformation and also can give examples of these changes. You can state and explain the law of conservation of energy using examples. And also you will be understand power and explain what it means and know its SI unit. Now the topic we are going to start is 13.5, energy transformation and conservation. Like electrical energy transforms in chemical energy and it transforms in mechanical and so on. Different forms of energy can change from one form to another in various situations. Like eating an apple. Eating an apple is a chemical energy, and after eating that we get the energy, so we do some work like riding bicycle, so it called mechanical energy. Same as in photosynthesis, sun gives light which helps the plant to grow. So sun gives light energy and it transforms into chemical energy. These changes of energy from one form to another is called energy transformation. Some examples of these energy transformations are given further. Example 1. Water stored in a dam has potential energy. When the water falls from a height, this energy changes into kinetic energy. Because potential energy refers to the energy at height and the kinetic energy refers to the movement of an object. The moving water rotates a turbine, changing it into mechanical energy. This rotating turbine then produces electrical energy. Example 2. In our homes, an electrical bulb or tube light changes electrical energy into light energy. For example, turning on the switch so the bulb can turn on. an electric heater, oven, iron changes electrical energy into heat energy. There are various examples like an electric kettle, hair dryer, electric heater, etc. An electric pump or motor changes electrical energy into mechanical energy. Let's take a short break. Welcome back to our classes. Example 3. An electric cell changes chemical energy into electrical energy. Putting two electrical cells opposite their charges into the water, it can help turn on the bulb. A solar cell changes light energy into electrical energy. And a thermocouple changes heat energy into electrical energy. Example 4. A microphone changes sound energy into electrical energy, while loudspeaker changes electrical energy into sound energy. Next, fifth example. A heat engine changes heat energy into mechanical work. When work is done against friction, the mechanical energy is changed into heat energy. For example, suddenly brake on a moving cycle, or rubbing hands into each other So these work which are against the frictions produce heat energy. During transformation of energy from one form to another, it remains constant. This is known as law of conservation of energy. For example, the energy transformations can be seen in photosynthesis, as solar energy changes into chemical energy of food. And second, bursting of fireworks, these are chemical energy it changes into heat, light and sound energy. Third is electrical bulb, which provides or produce electrical energy. It changes into light energy. Turning on the switch, that switch produces electrical energy and it travels to the bulb. Same for loudspeaker. And next is table fan. In there, electrical energy changes into kinetic energy, and physical exercise like running, in this chemical energy which we get from food changes into muscular energy. The next topic we are going to start is 13.6 power and its unit. We often hear statements like 1/4 half, or we can say 1/4 horsepower motor is enough for a cooler in summers. And if we compare it to the 1 horsepower motor, so 1 horsepower motor works faster than a 1.5 horsepower motor. But what is horsepower? Horsepower is a unit of power, and power tells us how fast work is done. It means the amount of work done in a given time. And here is the formula through we get the power. We get the power by dividing the work done and time taken. And in short, the SI unit of power is what? Or we can write it down as W. One watt is the power used when 1 joule of work is done in 1 second. Power is also measured in horsepower, or we can write down it as HP, and 1 horsepower is equals to 746 watts. Now here is the activity for our better understanding. In this, climb the stairs slowly and then run up to the same height. Which case do you get tired more and why? Your answer would be you feel more tired when you run. And the reasons is because you do the same work in less time. Doing work in less time, it means using more power. Do you know about 1 joule of work is done when you lift a glass of water from the table to your mouth? A football player uses about 150 joule of energy to kick a ball to a height of 33 meters. A 50 kg adult does about 5000 joule of work which climbing the stairs of a single story building. Pulling a 20-liter bucket of water and pulling 20-meter deep well requires about 4000 joule of work. Let's take a short break. Welcome back to our classes. let's look what we have learned so far. We have learned that work is done when a force acts on an object and the object moves in the direction of the force. We have learned how to calculate work. We can calculate work by multiplying force and displacement. We know the energy is the ability to do work. A body can do work because it has energy which gets from food. Energy exists in many forms like mechanical, heat, light, electrical, sound, magnetic, nuclear, etc. We know that mechanical energy is of two types. First is potential and the second is kinetic energy. Energy can change from one form to another, and this change is called energy transformation. During energy transformation, energy is neither created nor destroyed. This is the law of conservation of energy. And at last we have learned what is power, and power is the rate at which work is done, and its SI unit is what? Now we have completed our lesson. So now let's do some exercise. Choose the correct option. Is this work done or work 0? When force and displacement are in the same direction. So is there work or no work? Next, when force and displacement of the body are in opposite directions. When force acting on the body is perpendicular to the direction of the displacement of the body. And fourth, when force makes an angle with displacement. Now the answer is C. Now fill in the blanks. The ability to do work is called energy. Second, the SI unit of all forms of energy is called joule, or we can write it as J. Third, a motor converts electrical energy into which energy? Mechanical energy. And fourth, an electric heater converts electrical energy into dash. It converts electrical energy into heat energy. A microphone converts sound energy into electrical energy. A loudspeaker converts sound energy into which energy? It converts sound energy into electrical energy. We have completed our lesson, and thank you for paying attention.